For our mapping overview, we'll be considering three rectilinear forms: a cardboard box, a wooden table, and a folding wooden chair. But I remind you, we're not drawing these items. We're finding the relationships that exist between these edges and intersections of this grouping. We're going to start by finding the outer boundaries of this group, and we'll begin by holding our sighting device, our stick, horizontally as we can. We'll bring it down from above the grouping until we slowly lower it and hit the first intersection or edge that we meet. While it's resting there, you're going to look around and you're going to see what other edges or intersections or corners exist close to that stick. When you take the stick away, try to visualize where it was before, much like you see at the top line of this blue box. Next, you're going to find the bottom boundary. You'll hold the stick horizontal again, and way below all the grouping, you'll slowly raise it until, bonk, you hit the lowest point or edge that you meet in the grouping. While it's there, you're going to look around and you're going to check and see what other intersections or edges are nearby to that lower boundary. And again, when you take the stick away, try to visualize that lower boundary where the stick was, just like the lower blue line on the blue box that you see here. Having established the top and the lower boundary, now we're going to check the sides. We'll start with holding our stick perfectly vertical, as straight up and down as we can. We'll start off to the right, and we'll slowly move the stick left until, bonk, we hit the first edge or intersection that we encounter. While it's there, we're going to look around again, and we're going to look for edges and intersections that might be nearby. After we've done that, you take the stick down, but you still try to envision that right boundary. And finally, we'll check the left side. Again, you're holding that stick as straight up and down as possible, and off to the left. You'll slowly move it to the right until, boom, bonk, you hit the edge or intersection that you come to first. You let it rest there, and you look around once again to check and see who's nearby. Once you've done that, you take it back down. You still envision as if it's there, and we should have a good idea of where those boundaries are, even when the stick's not up there. Now that we've familiarized ourselves with the grouping that we're going to translate, let's take a look at our paper. Right here, I've got 18 by 24 inch Strathmore drawing pad ready to go, and we will start to consider which way would we orient our paper. Now that's going to depend on the still life, on the grouping. The question you ask are the boundaries of your chosen group, are they wider or are they taller as a group? So in order to figure that out, we're going to break the stick out again. This time, we're going to hold it as horizontally, as level as possible once again. And we're going to align the left end of the stick with the left boundary of the grouping. And our thumbnail will be placed where the right boundary of the grouping exists. We'll then rotate that stick into vertical position and compare the amount that we got sideways with it vertically. We'll align the top of the stick with the top boundary of the grouping, and we'll let our thumb end up wherever it is. In this case, it's below the lower boundary, and that means that the height is only 5/6 of the total width. That means your grouping is wider than it is tall, so that means you're going to orient your paper horizontally. This is also known as landscape mode. So we familiarized ourselves with the overall grouping and the boundaries, and we've got our paper situated. So the next thing to do will be to identify an edge in the grouping that we can use as a unit of comparison. So what's a unit of comparison? Well, a unit of comparison just simply means where we take one length within the still life, an edge within a form. And we use that edge to compare distances between intersections and edges of all the other forms within that grouping. Ideally, your unit of comparison, the edge that you use, should be something that's really clear and easy to find. It's easy to come back to. It also should be smaller compared to the overall dimensions of your boundaries of the grouping. So basically, you're looking for an edge that is on the smaller size of medium compared to all of the other edges that are up there. Usually a good candidate, and in this case, we have a box, that gives us a true vertical with very clear corners or intersections that we can go back to and find each time. For this grouping, we're going to use that box that you see on the table, and we're going to use the central vertical edge as our unit of comparison. So here we have the box, and we have that central vertical edge that we're going to use. You'll see that the top one, the top corner of that edge, I'm referring to as intersection A, and the lower one as intersection B. So in this image, I've highlighted the unit of comparison that we've identified and selected for use. Also, we can see the boundaries as they've been identified and we've become familiar with. For our next step, it's important for us to consider how those relate to each other. To note approximate position, left, right, high, and low, of our unit of comparison to those boundaries. So looking at that unit of comparison, we're going to ask ourselves, where is it? It's higher or is it lower? Is it closer to the right? Is it closer to the left? Is it kind of in the middle? We're also going to think about how tall is that unit of comparison and how does that compare to the overall distance of the height of our boundaries? How much room is it taking up that way? These comparisons are important because we're going to start translating that back to the paper. We're going to think about how it related to the boundaries. And looking at our paper, thinking about that as the basis for our translated composition, we're going to decide where we think it should go. Looking at our paper, we're going to estimate the left-right position. Where we think it should go, we're just going to drop a vertical movement and record that, drawing a vertical line, in the left-right position we expect it to be. And we'll probably just give it enough length to say it's going to be in this range of high and low. But then we're going to make a more definite statement by doing cross marks. One above that's going to say this is where the A position of the intersection should be, and here's where the B intersection position should be. It's our first step in attempting an analogous set of relationships that we're translating onto our paper as to those that we're looking at in our grouping. Admittedly, it's just an estimation of where things will go on the page, where this unit of comparison would exist on this page relative to those boundaries. But we will make some choices later. It's a starting point, so don't put too much pressure on yourself. Just take your best shot, and we'll take it from there. As we move forward, I'm going to refer to this one as your paper schmedium instead of your paper unit of comparison. It's just faster to say it that way. And I choose schmedium because when you chose in your still life, in your grouping, an edge, it needed to be the smaller size of medium, so schmedium. I'll use the word schmedium and paper schmedium for a quicker, easier way of saying unit of comparison and unit of comparison on your paper. Instead, I'll say schmedium and paper schmedium. So now we're going to take this opportunity to check how that estimate, how accurate it was. We're going to start by going back up to our grouping and identifying the B intersection of our schmedium, our unit of comparison. We'll start off by locating its position relative to the left, right, high, and low boundaries. Our method of finding its position relative to those boundaries will be pretty accurate. And then we're going to go to the paper and we will do a similar kind of activity. We'll use the same method to find an analogous set of relationships on our paper. Using the information that we find when we're checking from our B intersection to the boundaries in our grouping, we'll take it to the paper, and then we'll take that information to find the boundaries based on the B intersection of our paper schmedium. So here again is our unit of comparison, our schmedium, and the boundaries for our grouping. We're going to take our stick. We'll hold our sighting device at full arm's length away from us. It's very important to make sure that that distance between our eye and our stick is consistent. So in order to do that, we keep our arm fully extended at all time with no bend so that that is consistent. What we'll do is hold the stick as perfectly vertical as we can. We'll align the top of the stick with the A intersection of our schmedium, and the B intersection of our schmedium will rest on our thumbnail. That gives us our amount that we can move around our grouping and find the relationships, the distances between new intersections. For our first comparison, we're going to find out how far it is from our B intersection down to the lowest boundary. We'll take our stick, we'll take that amount, and we'll move it down so that now the top of the stick is even with the B intersection and our thumb is moved down. That gives us an increment of 1. Then we'll move the top of the stick down to where our thumb just was. That will give us another increment. We cross the boundary at the 4/5 of that second comparison. So our total distance from the B intersection to the lower boundary is 1 4/5. Next, we're going to check where the leftmost boundary is. We'll do that by getting our schmedium and flipping it horizontally. We'll put our thumb even with the B intersection, and we'll walk it over. This is 1 unit, and I'm making note of where the end of the stick is because I will put my thumb there, and I'm going to repeat that, walking that stick over to the left until I find that left boundary. So from my B intersection over to my left boundary, it ends up that it's 3 and slightly more than 1/2. So 3.5. It's okay to say slightly more or slightly less because as long as you know what that meant visually, it'll translate. Whenever you're doing this, I can't stress enough. You should try this a couple of times each time, so that you see if you get the same, in this case, 3.5. If it doesn't agree on that second try, go ahead and try it a third time. What you're looking for is consensus and something that's reliable. Don't just do it once. It's sort of like the old adage, measure twice, cut once. Here, it's just do it a few times because there are a number of variables that could cause that number to be off. And so if you do it a couple of times until you find that consensus, then you'll be good. So after finding that left boundary distance, now we're going to locate the right boundary. Again, you're taking that schmedium, you're flipping it horizontally. In this case, it only takes less than 1 or 3/4 of our schmedium to cross that boundary. So 3/4 is what we need to keep in mind here. Now we'll take the numbers that we found in our grouping comparisons and we're going to take it to our paper. We're going to find out where the edges are based on the number from the B of our paper schmedium. We're going to begin the translation to paper by taking our stick and laying it on our paper. And we're going to put the top of our stick even with the A of our paper schmedium, and we will use our thumbnail to designate the bottom of the B intersection. We'll begin by finding the bottom boundary. We'll take the paper schmedium amount and we'll count down from the B intersection 1 4/5 to find that bottom barrier. Then we'll flip it sideways and we'll go from that B intersection of our paper schmedium and count over to the left 3 and slightly more than 1/2 to find our left boundary. Then we'll do our right boundary and we take our paper schmedium, it's horizontal again, and we move right from the B intersection and find 3/4 over to get our right boundary. One thing we didn't mention, that's that top boundary. Because that was only slightly above our A intersection, I have a great idea of where it is, and it's a very small amount, so we're pretty accurate. So hey, we were just estimating the placement of our paper schmedium, and now we know where our boundaries are going to be based on the placement and size of that paper schmedium. And hey, you know what? It's not bad, but we have the opportunity to make it better. That blue line tells me where the grouping, when it's translated, where the outer boundaries of that is going to touch. And it looks really like it's hanging to the left more than I want it to. It's maybe a little small too. So I can make a better choice, and it's easy, and it's built in, and you should make a better choice. And my choice would be, let's move stuff to the right so that it's not on that left edge of the paper. In order to move everything to the right, all I've got to do is take my paper schmedium and move him over to the right. When he moves, everybody else goes with him. So I have my boundaries now where I want. So that's a lot better. I'm much happier with where that's placed. But like I said earlier, you know what? I'm thinking I'm not really using much of my real estate. That blue rectangle, my boundaries, it's still kind of floating. It's not using all of my drawing paper surface. I'm not maximizing that real estate. So I need to enlarge that so that I get the composition that fills that page without being cropped or cut off that I want. So if I want my overall composition bigger, my boundaries larger, all I have to do is enlarge my paper schmedium. Anything I do to that paper schmedium, whether I'm moving it left, right, or high, low, and that's moving the boundaries left, right, high, low, I can make it larger by enlarging the schmedium. Or likewise, if it were too big, I could reduce the paper schmedium and those boundaries are going to get smaller too. It's just as simple as that. And you can see that here. I enlarged that paper schmedium, and so now when I count with that larger paper schmedium, those boundaries get bigger. The blue boundaries expanded. That's as easy as it can be. But here's the thing. You need to be patient. You may not find exactly the boundary placement for your translation that you want on the first, second, or even third try. Let yourself move it around. make it larger or smaller until you get the boundaries that you want and you deserve so that you can play the game the way you want to. The mapping game. So through trial and error, moving things around, I finally have the paper schmedium that I want in the place that I want it. Meaning it's going to let things fall on the page in a way that I want. So let's head back to our grouping and get some numbers that we can start translating. So we're back here and we have our real schmedium, our unit of comparison for our grouping, and it has now a corresponding paper schmedium that's located. We can start to use this and move back and forth so that we can translate these relationships. So we have one set of A-B intersections found on our page. Now we're going to find another set, and we're going to start with this B intersection. We'll locate it relative to the AB that we have established on our paper and its corresponding schmedium. Once again, we'll start by getting our unit of comparison. Arm fully extended, top of the stick even with the A intersection, and the B intersection resting on your thumbnail. We're looking for that intersection right over there. To do that, we'll flip that schmedium sideways, horizontal, and we'll see that from the B intersection of our schmedium, it's 1/3 of that unit of comparison over to the right to that new B intersection. Then we're going to do the same thing on our paper. We're going to go get the paper schmedium, flip it horizontally from that B intersection, and you'll see where 1/3 is. We're going to take and mark that placement. That mark that tells us how far to the right the B we're looking for is should look something like this. For every intersection that we're looking for, we need to find out two things about it. One is where it's located left and right relative to other established intersections and edges, and the other is how high and low it is. For the B that we're looking for, we just found its left-right position. But now we're looking at where is its height. What's its high-low position relative to the AB that we have established. I'm laying a horizontal stick on the B section that I'm looking for. I'm pulling it all the way across and looking at where that stick exists, like the needle on a gauge between the A and B of our schmedium. That's a pretty accurate way of finding. I call it gauging. And that finding between 2 points is really far more accurate than actually using the comparison method that we just used. Whenever possible, we're going to lean into the gauging method. You might be a little hesitant to believe me, because the other one seems like measuring. Well, it's not. It is actually prone to more variables when you do that comparison and counting. It sounds more convincing because it has numbers. But actually the gauging is so much more accurate. I'll go give you this example. And that is, if you have a watch, an analog watch, and there are no numbers on that watch, but you have hands on there, I'm pretty sure you know what time it is. Or if you're driving and you look at your gas gauge and you see where that needle is located, you have a very good sense of how much gas you have left. So the gauging method is far more reliable. It's easier, it's faster. All good things. It's only when we can't use gauging, if there aren't two established edges that we can, or intersections that we can compare them to, we have to rely on that comparison and counting. We only do it in that instance. And that accuracy of using this gauging method extends to our translation on the paper. You can see with that yellow line, I'm noting where it crossed our schmedium and making a little mark on where it hit. I'm then pulling it off to the right, and it's creating a cross section. That's the B intersection that we just found, the new B intersection. You'll notice that I erased or got rid of the part that crossed over our original paper schmedium, and I only left the little plus. The reason you do that is that was a guideline. And once a guideline has served its purpose, in this case locating the height, you get rid of it immediately so that you don't get confused and start thinking that, oh, this is the edge of a form. Once a guideline has served its purpose, you erase the guideline. So awesome. You've got on your paper now comparison edge A intersection and comparison edge B intersection. And you've got the new intersection B located. You know where it goes. So here's the thing. The B intersections, the one you just found and the one you had before, they're connected with an edge. So you go to your paper and you move through it with a line. It's going to look something like this. So you've got the B intersection. You need the A that goes with it. Now, that A intersection is actually directly above the B because that edge is a perfect vertical. I know it doesn't look like that in this photo, but the camera lens gives it a distortion that when I'm looking at it right here in real life, it's straight up and down. So I know that that A is directly above that, and I'm going to drop a vertical line on my paper through that new B, like this. That means I know the left-right position of the new A that I'm trying to find, but I don't know how high or low it is. So to do that, I'm going to go back, get my schmedium, move it over to the right, so that my thumb is even with the new B. And I'm going to see that the distance between this new A and B is slightly less than one of my schmediums. So to translate that, I'm going to go back to my paper, take slightly less than one of my paper comparison unit, my paper schmedium, and compare up from the new B intersection to the new A intersection. I'll mark it, and it's going to look a little something like this. And hey, you'll notice that these two A intersections, the old one and the new one, they're connected with an edge. So you're going to move through those two A's with a line, and it's going to look like this. Whoa, how cool is that? So let's go find another pair of AB intersections. Let's start by finding this B intersection. We'll find this B the same way we found the other one, but now we have extra information. We can put a horizontal across there and we can gauge the height of this new B intersection by comparing it against two established vertical edges. And just like before, we're going to take that information back to our paper. You'll see that the yellow line is crossing the other two verticals, and I can tell exactly where that goes, and I'm going to drop a guideline. That gave us the high-low location of the new B, but now we've got to figure out where its left-right position is. We're going to do the same as before. We're going to get our schmedium and flip it sideways, and we're going to see that it's 1/2 of a schmedium off to the left. And again, we're taking that information back to the paper. So we'll get half of our paper schmedium, and we're going to flip it on its side and over to the left, and then we'll mark that location left-right. That's going to give us something that looks like this after I erase that guideline that's already served its purpose. And hey, what do you know? These two B intersections, they're connected too. So we'll move a line through those on our paper, and it's going to look something like this. We know that that A intersection that belongs with this new B intersection is directly above it because it's a perfect vertical. So we should drop a vertical line through that B. Now we got to find out how far that A intersection is above that new B intersection. So we're going to go back. We're going to get our medium so that we can compare it over on our new ABs. I move that medium over to the left, putting my thumb on the new B intersection, and I see that the A is 4/5 of 1 above it. Taking that information back to my paper, I'm going to get 4/5 of my paper medium, and then I'm going to move it over and up from the new B to mark the new A intersection. And check out what I'm noticing here. These two A intersections, they're also connected with an edge. So hey, go move a line through them. And when you do, I'm pretty sure it's going to look a little something like this. You know, we are off to a pretty good start, if I do say so myself. We've got a solid foundation. We've got intersections and edges that we can go out and find more intersections and edges. We can start mapping this entire composition and find all the relationships now. And we'll start by finding the boundaries of the other two forms, the table and the chair, subdividing up the field of our original boundaries further. We can start by finding the boundaries or the bonks of the table. We'll start by trying to find the right side of the table. We'll get the medium and flip it on its side, and we'll see that it's 3/4 over from the center. We may think we already know the location because it is the right boundary, but now that we have more information and edges, we always want to check to make sure that that agrees, and we want to defer to what we find based on more information. I can also do a double check by getting the medium and flipping on its side, but checking how far over it is from the rightmost edge. If they agree, I'm in really good shape. Using the same method, I can check for the lower table boundary and the left table boundary and make sure that those are where they need to be. You'll notice that I've got the table box intersections where the edge of the table hits the edge of the box. When any edge hits any other edge visually, that constitutes an intersection that you should find and is just as important as an intersection that we would call a corner of a form. All of them are equally valid and helpful. So taking that information to the paper, we saw that from the right edge it was 1/2 of a medium. On our paper, we'll get half of our paper medium. We'll turn it horizontal and find the right boundary of the table from the right edge of the box. You can also see that the lower boundary was 1 4/5 from the B intersection of the center edge, and the left boundary of the table was slightly over 1/4 from the left edge of the box. Now it's time for the chair. I'm going to bonk the right edge of the chair with a vertical stick so that I can see where that edge exists. This is a lot like how we started off with the overall finding of boundaries and bonking, but now we're doing it on individual items. We get our medium, and I'm going to turn it sideways, where I'll see that from the left edge of the box, it's 5/6 of one of our mediums. Next, I'm going to go back, get that medium again, flip it sideways, and I'm going to check from the right edge of the chair and count over to the left boundary of the chair. I'm going to see that the distance between the chair boundaries is slightly less than 2 of our comparison units. And of course, I'm taking that information back to my paper. I'm going to get 5/6 of that paper medium, and I'm going to go over from the left edge of the box, and I'm going to find the right boundary of the chair. After I've done that, I'm going to get the full paper medium and go over slightly less than 2 to find the left boundary. Both of the lower boundaries are even. So I know where the right boundary, lowest boundary is. So I know where the left lowest boundary is because they're even. Taking our horizontal stick, we're going to rest it on the uppermost part of the chair. That's how we'll find that upper boundary. Then, taking that stick all the way across, we're comparing it against the other A-B intersections that we have over to the right. That should give us a really accurate placement for that upper boundary of the chair. We'll translate that to our paper by taking the stick as a horizontal and comparing it against our AB intersections on the right, pulling it across, and we'll move through with our Conte to make that top guideline. Looking at your paper, this is what you've got right now, and you're in good shape. So looking back at our grouping, we know that we have the boundaries for all these forms, as indicated by the blue boxes. But you'll also see that our next step will be to find the intersections to the tabletop. So setting out to find that set of intersections, we're going to, of course, get our schmedium, and we're going to drop it down and compare the distance between the B intersection and the height of our new intersection that we're looking for. And we see that it's 1/4 of a schmedium below. I know it's left-right location because it hits on that boundary that we've established. Next, I'm going to notice that the intersection to the left is exactly even with that because I have a horizontal that shows me this to be true. So all I have to do is go to my paper and find that, move it over with a horizontal. I'll also check with a vertical stick, and I'm going to check its left-right location. You'll see that I have looked at the distance between the left boundary of the table and the left boundary of the box. That gives me that really clear identification of that A intersection's left-right orientation. You'll remember that we've already marked 2 other intersections relating to the tabletop, and that's where the tabletop runs into the box edges. Also, the left box intersection and the upper left corner of our table are even, so we know that it's directly to the left of that box intersection on the left side. So that locates all of our tabletop intersections. And now what we need to do is move through them where they're connected. So looking at our paper, this is what that's going to look like. Based on that information, now we're going to find the A intersection of the table leg. And we're going to ask, where does it hit the tabletop? What's its location left-right? Then we're going to find the corresponding B that goes with that A intersection. You're going to find the left-right position of that B. We'll run a vertical straight up from the new intersection, and we're going to note where that lands between the 2 B intersections above it, as indicated by the blue. That takes care of the left-right position, and the high-low position we already know because that hits on that bottommost boundary of our table guidelines. And hey, when you've got an A and B that's connected by an edge, you move through them. Am I right? It's just what we do. And taking it back to the paper, you can see what we did and how we translated it. You can see how we located the A and the B. The blue dotted lines are the vertical positioning. You'll also see a third blue dotted line off to the right, and that's us finding the next A position for the other leg. Then we locate its corresponding B intersection, just like we did before. Same process, and it moves us forward, and our paper is looking like this. That blue dotted line, that's the vertical that we use to locate the left-right position of that B. So looking here, you can see that I've done a few things. I've gone through and I've located the other edges that are parallel to the major ones I found earlier. The other thing I did is I got rid of that guideline. That's the outer boundaries of that table. I don't need it anymore. And we know that when we have a guideline that served its purpose, we what? That's right, we get rid of it. And yet another thing that I'm doing, you'll see that I'm looking for the A and B that belongs to yet another leg of the table. And because I've got so much information now, it gets easier and easier because I can just gauge, use my stick either horizontally or vertically, and compare its location to the other intersections. You'll see the blue dots here, the dotted lines. Those are both vertical and horizontal positioning of the stick that I used to just compare that B location and that A location. And that's really reliable. As a side note, I know that this new A-B location are pretty accurate because it's parallel to the front leg that is also diagonal. I can use this knowledge that they're parallel as a way of verifying that I've found the correct placements. If they're not parallel, then that just tells me I need to go back and recheck the positions of my intersections because somebody's off. Then I'm going to go ahead and I'm going to locate the final couple of intersections and move through those. And in this case, I have yet another way of sort of verifying that I found those intersections correctly. You'll notice that the angle that is shown here in that yellow angle, we know that this crossbar is parallel to the left and right edges of the tabletop. And knowing that one point perspective says that if we have parallel edges that move away from us in space, they will appear to converge. If they converge in a consistent manner, then I did find all of those relevant intersections correctly. If that's not the case, well, that's good news too. It means I just found another way to tell me that I need to go back and check some of these intersection placements and move them towards greater accuracy. So at this point, I've got a lot going on and I don't want to get confused. So I'm going to go ahead and clean this up a little bit. And by clean up, I mean just to get rid of some of the unnecessary lines that are there that might confuse me. I'm not getting rid of those intersections though. You can see that those extensions still exist. I'm only cleaning it up enough that I feel confident that I can see what's going on. So I can understand you might be intimidated by that chair form we're about to tackle. But you know what? I put it off till the end because now that I have all of the information on the right that I can use to compare over, it's going to make this chair, or finding the form and the intersections, a piece of cake. I can find this A intersection pretty easily because I know its left-right position is on the boundary of the chair. And all I have to do is take a horizontal stick, take it all the way across and compare it against all of the intersections on the right and see who it's even with or above or below. And I can get its height, bring it back over, and there it is. And as easy as that was, the B intersection might even be easier because we know its high-low position is on that lower boundary and its left-right, well, we can see that it's just a bit to the left of the right boundary of the chair. So there it is. Then once again, we use our good body mechanics and our big muscle groups and we're going to move through that A and that B. It's all good. I have a couple of parallel edges to that AB I just found, so I'm going to find those. And then I'm going to go back and I'm going to find this other AB. And again, it's just taking my stick and getting the high-low compared to what's happening off to the right and the distance between the left boundary and where the A intersection goes left-right. Again, we have an opportunity here because these two ABs that we're just finding here, well, they're parallel to each other. So that gives us that cross-check opportunity. And if they don't end up locating and giving us the parallel, we know to go back and to refine them better. We've got a couple of A intersection opportunities that are pretty easy to find. We're going to put that horizontal out there, compare it off to the right, and get the height of these two new A's. The B that belongs to the A on the left, it's easy to find just like before. It's just to the right of that left boundary. And like always, once those are set, we're going to move through those A, B's because they're connected by an edge. And here we can see how we found that second B with the blue dotted line with the arrows. That shows that we used our horizontal stick and compared them together, and we know that they're even. So that's how we found the height of that second B. The yellow arrows, those tell us the location of the intersections where the seat of the chair moves in and hits these legs. The easiest way to locate those is to just look at where that intersection exists relative to the other intersections that you have there on the chair, like where the legs cross. Is it a little higher? Is it a little lower? Compare that to all the other positions that exist there. And also you can take it back over to the table on the right as another way of making sure your location's good. From here, I'll just continue to play the game that we've been playing in terms of high-low, left-right locations of other A and B intersections. And then you can see here that I went and found all of the parallel edges that exist, and those are there for us. You'll also notice, though, that, wait a minute, look at the top of that box. Where did that come from? How did you figure that out? Because it looks like we're almost there. And we are. So here it is. It's the last intersection that we need to find. And I put it off till last because, well, I wanted to keep you waiting. No, really, it's the one that gives people the biggest difficulty. But really, you got this. Because this is exactly the game you've been playing this whole time. The only difference is this happens in a little bit of a tighter area, so that's what makes it difficult. And it also shows, if it's off a little bit, it really calls attention to itself. So just like always, you're going to find the left-right position of this intersection, and you're going to do it by comparing it to the intersections that are below it. You're going to put that vertical stick up there, and you're going to note the distance between those two edges, kind of as a gauge. How far to the right is it from the left, or how far to the left is it from that central vertical? You're also going to locate its high-low position. You'll notice the comparison between the two distances that I've shown in yellow. It's very important that you see that those top two lines are very close together. You'll also notice that that top bonk is only a hair above the A intersection of the left side of the box, so it's not up there very high. And with those two considerations, we've located the last intersection, which is also the highest intersection in your composition. And you know what? I kind of think you see this coming. We're going to move through those intersections, just like you expected. So this is what it's looking like right now. Oh, wait a minute. I left a guideline down there at the bottom of the chair. Whew. That's better. Okay, so I am going to take a second and point out that blue dotted line. That's that vertical that we use to compare the left-right placement of that back intersection. It's worth noting, and it's easier to see here, I think. And like I did on the table, I'm going to go on the chair. I'm going to erase out those areas where the lines are showing, but it's actually blocked out. Those are actually blocked out by the form. It'll make the form more understandable. It'll make more sense. So when I'm clearing it up, when I'm cleaning up, I'm only doing that ever to just make things more understandable, never to make them neat or clean. I'm just trying to make it understandable for myself. So after cleaning it up, making a few adjustments here and there, and maybe a few minor additions, this is what we're left with. I'm hoping that this review helps you make more tangible this as a tool, to be able to use it in an informed way that helps you find things that you don't understand easily, that you find the relationships, and you end up with something that, hey, in this instance, it looks like a table and a chair and a box that's on that table over there. I understand these forms, and they're extremely accurate. Remember that this is mostly valuable for when things are very complicated. That's when you lean into this tool. And as we move forward into more complex forms, it will help you find easier and better. Finally, please remember, this isn't meant to be a way to make a picture. This is meant to be a way for you to better understand. Take care. We'll talk soon.
Well, I look at it myself as the beginning, really, of an exploration. That's the reason we're exploring. You don't know what you'll run into on an exploration. What the sky looks like, what the stars look like. Do they still twinkle, or are they...